Okay, before we begin, I just want to confirm that you guys can hear me and see my screen. So please type in the chat whether you can hear me. Okay, perfect. Perfect. Okay, so Assalamu alaikum and good morning, almost afternoon to everyone. Welcome to the inaugural lesson for maths grade 11. My name is Abdullah Ali and I'm going to be your guys' tutor for the rest of the year, right? Today's lesson will be starting with algebra, like algebraic expressions, factorizing. Okay, and so going forward, if you guys have any questions, so please feel free to ask them in the chat, in the Zoom chat, in the Q&A, YouTube. I'm not sure if the chat is enabled, but yeah, if you guys do have any questions there, please go ahead and ask them. With regards to the notes, you guys are free to take notes if you want. However, the notes that I will be doing on the screen, the work that I will be working with you guys through, will be sent to the WhatsApp group by latest tonight. Okay. With that being said, I think we're ready to start. Okay, cool. So we're going to start off with a basic revision, okay, as I did with like most grades in maths and when it comes to algebra. We are going to talk about the difference between, okay, so different numbers. We're going to talk about the difference between non-real numbers and real numbers. Okay, so as you can see, we have non-real on the right-hand side, and there's an indication that says inside of a third less than 0. So it says here as well, sometimes referred to as imaginary numbers. So non-real numbers are imaginary numbers, or simply put, okay, it is a number that inside of a third, there's a negative. Okay, inside of a third, there's a negative. So it could be -3, for example, or -7. This is what we would refer to as a non-real number. Okay, anything else is what we would refer to as a real number. Okay, so in this case, whenever inside of the third, a value inside of a third is greater than or equal to 0, that would be referred to as a real number. Okay, so when we put that number inside of a third, it's greater than or equal to 0. So basically, it means it's either 0 negative, or it's positive. Okay, that is what we would refer to as a real number. Okay, then within real numbers, so non-real numbers stop there. Within real numbers, okay, we categorize them further. The first of which are rational numbers, the second of which are integers, whole numbers, and natural numbers. Okay, so all whole numbers, natural numbers, integers are rational numbers. All whole numbers and natural numbers are integers, and all natural numbers are whole numbers. However, not all integers are natural numbers. So that's why we can see the different levels of categorizing. Okay, we can see that within rational, we have integers. Within integers, we have whole. Within whole, we have natural. Okay, but within natural, we don't have rational. So that means basically that not necessarily that natural numbers could be integers. Okay, but however, for example, an integer is you could find integers that are natural numbers as well. Okay, so when we talk about rational, we see, let's just highlight this a different color. When we talk about rational, we see the contrast between rational numbers and irrational numbers. Okay, now the difference between those is rational numbers, firstly, can be expressed as fractions. Okay, irrational numbers they give examples, pi or √2, for example, and that they say that all decimals that cannot be written as a fraction, okay, as a proper fraction. Okay, so irrational numbers, the simple understanding of it is when a number has an infinite amount of decimals. Okay, let's talk about pi, for example. If you have to insert pi in your calculator, pi we generally know is 3,14, but actually pi is 3,14,15,92,654, and so on and so forth. It goes on till forever, right? If it stops at that number because that's what your calculator's memory can handle, but actually pi's numbers go on till forever. Okay, so we actually don't know its last value because it's always adding more numbers to it. Okay, and the same applies with root 2. If we put root 2 in our calculators, we get a never-ending decimal, 1,414, so on and so forth. So that is a type of number that we refer to as an irrational number. Why? Because it has this terminating decimals. Okay, the decimals don't end. Okay, and we don't actually know the entire value of it because the numbers keep going on and on. That's an irrational number. However, a rational number, it can be expressed as the proper fraction, and we know the entire value of it. An example is 2. There's nothing more to it, nothing less to it. It's just 2. We know the entire value. Let's use a fraction, 3/5. 3/5 is actually equal to 0,6. That's just one decimal. We know the entire value of it. It doesn't go on forever. Let's just say 20,5, another decimal that has a certain value. Okay, so irrational is when the digits continue on and we can't like have we don't know the entire value of it. Okay, then we move on to integers. Okay, so integers are positive and negative whole numbers. Okay, whole numbers. Okay, let's look at whole numbers and natural numbers. We can actually start at natural numbers and work our way back up. So natural numbers, how I like to say, is the way we count naturally. Okay, so when you're playing hide and seek, okay, I hope no grade 11s are playing hide and seek, but when you were 8 and you played hide and seek, and when you were counting, nobody started counting saying, okay, I'm counting 0, 1, 2, 3. Okay, maybe some people did. Never mind, bad example. But natural numbers are how we naturally count. 1, 2, 3, 4, 5, 6. Okay, nobody really starts from 0. And then, so that's natural numbers. Then when we deal with whole numbers are natural numbers, but including 0. Okay, I hope that makes sense. Natural numbers, including 0. And then integers, one above, are our positive and negative whole numbers. Okay, so integers deal with basically they add on those negative numbers as well. Okay, so that's a quick revision of our numbers. Okay, we'll come back. Okay, so this is just a summary of it. We will come back to it because we still going to deal with inequalities, but basically for now we see that real and non-real summarized define as within a surd greater than or equal to 0, that is a real number, and a non-real is within a surd is less than 0, that is a non-real number. Right, now that revision is done, we're going to go through trinomial factorization, and we're going to revise trinomial factorization as well. So the first we're going to learn is through factorization, and not by using the quadratic formula. We're going to learn how to factorize a trinomial. I know maybe many of you are still using the quadratic formula, which is fine. However, it is a good skill to know how to factorize as well. Okay, so trinomial factorization. Okay, your first step is you always want to look out for your HCF, or your highest common factor. So highest common factor is essentially a number that can go into each term an exact amount of times. In this case, I can take my common factor of 2. I'm left with x squared minus 7x minus 30. Okay, so you always want to be aware of your common factor, right? Initially, it's going to make your factorization easier because it's going to make the numbers smaller. So now that I've taken that common factor, now I can factorize this trinomial. Let's just talk about what is a trinomial. A trinomial is a mathematical expression with 3 unlike terms. So if you look at this, actually this, I've created a trinomial equation. But nevertheless, here is x squared, here's an x, and here's a constant. So 3 unlike terms create that trinomial. I can have a binomial, which would have 2 terms. I can have a monomial, which can have 1 term. Okay. Now, how do we factorize? So the first step to factorizing is you're going to open up your brackets. Okay, you're going to open up your brackets, your factors, essentially, these are known as your factors. Now, with our factors, right, we are going to use, right, so the steps are as follows. We are going to use the factors of the first and the factors of the last. Okay, with the factors of the first, I am going to place them in the first position in each bracket. With the factors of the last, I'm going to place them in the last place in each bracket. Okay, factors of the first, I'm going to place them in the first place in each bracket, and factors of the last, I'm going to place them in the last place in each bracket. Now, the factors of the first term are simple. The factors of the first term are, it's x squared. So the factors of x squared are x times x, so x and x. So there's only one option for x squared, and that's x times x. So both factors are the same, so it doesn't matter if I put the x here or the x there, because they're the exact same factor. So I put my x there in the first place of the first bracket, and I put my second x in the first place of the second bracket. So that's the first step done. Okay, I use the factors of the first term to add values into my factors. Now let's talk about the factors of the last term. Now the factors of 30, okay, the factors of 30 are multiple. So let's start off with them. I have 1 and 30. Okay, I have 2 times 15. I have, so I'm just writing them like that. Okay, 3 and 10. I have 5 and 6. And these are all my factors of 30. Okay, so now which ones do I choose? That's the thing, because I'm telling you that you need to choose the factors of 30 to input in the second places of each bracket. But now, which ones do I choose? So remember, when you work with factors, you work with factor pairs. So 1 works with 30, 2 works with 15, 3 works with 10, and 5 works with 6. So if you're going to choose 1, you're going to have to choose 30. If you're going to choose 2, you're going to have to choose 15, and so on. Okay, your factor pairs are important. Okay, so ideally, which one you want to choose? Now, this is really important. Okay, so listen carefully, right? Determining which ones to choose. So my first step is, okay, to look, well, you need to look at the middle term either way, but to look at the middle term. Okay, now with the factors of 30, you are going to choose one factor pair. So you're going to choose 1 and 30, or you're going to choose 2 and 15, or you're going to choose 3 and 10, or you're going to choose 5 and 6. Now, in your head, look, eventually at this point, you need to get to a point where all of this is done in your head. You're not going to be writing it out. But initially, to start off, if you are struggling, you can, you guys are correct. Initially, correct, 100%. If you are struggling, you can write out the factors to get used to it, to get the hang of things. Right? But which factor pair do you want to choose? You want to choose the factor pair that's going to give you -7, or even if you just say 7 for now. How is it going to give you -7 or 7? By either adding or subtracting. So you're going to take 1 and 30, for example. If I add or subtract 30 and 1, I can either get 31 or 29. That's not 7. If I choose 2 and 15, I can either get 17 or 13. That's not 7. If I choose 3 and 10, however, I can either get 13 or I can get 7. So that is indeed the factor pair that I'm going to choose, because when I add or subtract it, I get my middle term. Again, the signs we'll work on in a bit. Let's just do 5 and 6 just for the sake of doing it. 5 and 6, I can either get 11 or I can get 1. Okay, so that's not my middle term. I want to always obtain the value of the middle term. Now, in order to obtain the value of the middle term, yes, indeed, I choose 3 and 10. Now, I can't just plop 3 and 10. Technically, I can in some situations, but it matters, right? Where you're going to put the 3, where you're going to put the 10, where you're going to put the 3, where you're going to put the 10. Okay. Now, in this case, I have the same factors, x and x. So it doesn't matter actually where I put the 3 and 10 in this specific case. However, if I had to have something like 2x and x, yes, then it's going to matter a lot more. Okay, before we put in our factors of 30, let's talk about the signs, because we need to have a plus and a minus, or a plus and a plus, or a minus and a minus. How are we going to know which signs to use? So sign determination is determined as, sign is determined as follows. So you're always going to look at the second sign of trinomial. Okay, if the second sign of the trinomial is negative, that's what we follow. If the second sign of the trinomial is positive, that's the ruling that we follow. So let's go through the first one. If the second sign of the trinomial, by the way, the second sign of the trinomial is this guy here. This is the all-important sign that we're talking about. Okay, if the second sign of trinomial, of this specific trinomial, which in this case is actually negative, is a negative, the ruling that we follow is that one bracket gets a negative and one bracket gets a positive. Okay, so 100% of the time, one gets a negative, one gets a positive. So in this case, I'm just going to put negative, positive. Now, yes, it does matter. Sometimes the plus will have to go in one bracket and the negative will have to go in the other. But in this case, because both of our factors are x, the first factors are x, it doesn't make a difference, because if I put the plus there and the minus there, I've written the same thing essentially. Okay, so in this case specifically, yes, it does not matter. Let's just go through the next one. If the second sign of the trinomial was positive, so if this one was positive, both brackets get the first sign, again, of trinomial. So basically they're telling us if this sign was positive, so if it was negative, by the way, one more time, one would be plus, one would be minus. If it was positive, both would be minus. So this would be minus, minus. Both would take the first sign, not minus, sorry. Both would take the first sign. Whatever the first sign of the trinomial is, both would take it. And in this case, it's negative. However, we do have a negative. So yes, one is positive, one is negative. Okay, so I hope that makes sense. But that's just the sign determination in all cases, right? If the second sign of trinomial is negative, that's what you do. If the second sign of trinomial is positive, that's what you do. Now, one is negative, one is positive. Okay, now we can place in our factors of 3 and 10. Remember, our objective is not to get 7, it's to get negative 7. Okay, negative 7. So that's why strategically we have to place our 10 and our 3. If I put my 3 here and my 10 here, so I'm not sure which methods you guys use to check it, but you could use a method called outer inner. So you take the outer terms, you multiply them, and you add them to the inner terms. So the inner terms give me negative 3x, and the outer terms give me positive 10x. When I add these two together, I get positive 7x. That's not what I want. Okay. It's like part of FOIL. It's just testing the outer inner. That gives you the middle term. It's like a shortcut. Okay, it's not exactly FOIL. Okay, but you're just using the outer term, the inner term, multiplying and adding them, and it should give you the middle term. It's like a shortcut type thing. Okay, so yes, in that case, okay, again, like I said, I'm going through all the basics. At this point, you need to be able to practice. All of this needs to be done in your head. You're not going to be doing all these arrows and all of that. We're not doing we're not doing first and last. Okay, 3 minus 10 gives us negative 7, correct. Okay, so whenever you come into this issue where you actually have positive 7 instead of negative 7, that's a simple issue to solve, just because that just means you mixed it around. You were supposed to put the 10 in this side and the 3 in that side. Now, when I test the outer inner, I get negative 10x and positive 3x. Yes, now when I add these two together, I get negative 7x. Okay, so that's correct. Exactly. So must the 10 not be negative? Exactly. Okay, so now we are getting negative 7, which is the correct middle term. Okay, so that's how you do your trinomial factorization. Your first is to determine the factors from your first term, factors from your last term. So factors from your first term gave us x and x. Actually, then I did sign determination. So I needed to determine what signs are going where. So if the first sign was, if the second sign, sorry, of trinomial is a negative, one gets a plus, one gets a minus. If the second sign of trinomial is a positive, both brackets get the first sign of the trinomial. Okay, so in this case, we had minus plus. Thereafter, we get the factors of the last term to put it in the last places of the brackets. Factors of the last term are 1, 2, 3, 5, 6, 10, 15, and 30. So now how do I determine which factor I choose? Remember, I try to add and subtract to get someone's raising their hand. If anyone wants to raise their hand to ask a question, I would prefer you ask it in the Q&A or in the chat. Okay. So yes, again, we choose the one where in our head, we can minus subtract it or add it quickly to see if we get the middle term. And yes, then thereafter, that is actually the factors that we choose. Let's do some other examples. Let's do this one. Okay, I'm going to try and work a bit faster through this one. So I have x squared minus 2x minus 24. So I am going to do brackets. I'm going to utilize my factors of my first term. Factors of the first term are x and x. Sign determination. The second sign of trinomial is negative. Therefore, one becomes negative, one becomes positive. Does it matter which bracket I put it in? In this case, no, because both are x as the first factor. Then I look at the second thing. Okay, the last thing actually is the factors of 24. So I'm going to actually write it out. My pairs, 1 and 24. 2 and 12, 3 and 8, 4 and 6, and that's it. Okay, so again, I'm going to be using factor pairs. So now I need to think, okay, from these factor pairs, right, I'm actually going to minus and plus them. So I'm technically going to minus it. Which one can give me 2 or negative 2? So I'm going to try, you can try it out and say, okay, 1 and 24. Nope, that can give me 25 or 23. 2 and 12, that can give me 14 or 10. 3 and 8, that can give me 5 or 11. 4 and 6, that can give me 10 or 2. Exactly, perfect, right? But keep in mind, we have to have negative 2x. So when we do outer inner, we need to make sure that 6 is negative and 4 is positive. So that we get negative 6x plus 4x to give us negative 2. Okay, so that's important where we put it. We put it with which sign. That's very important. Otherwise, it's going to be wrong if you have x minus 4 and x plus 6. Okay, so I hope that makes sense. So that's trinomial factorization. And then taking it a step further, generally, if you are solving for x, you would equate each bracket to 0. Here you get x is equal to minus 4 or x is equal to 6. Okay, same can be said here. You guys will be getting this note so you can practice that example. Same can be said here. Let's look at something like this. Okay, so something like this is not trinomial factorization. Okay, something like this is a different type of factorization. Why are we changing signs? Oh, okay, simply let me explain, sorry. So I equated each bracket to 0. Thereafter, to solve for x, you need to isolate x. You need to leave x alone if you are solving for x. In order to leave x alone, you need to take the other number to the other side. When you take this other guy to the other side, that's why it changes signs, to leave x alone, basically. So therefore, I take it over to the other side, it becomes x is equal to minus 4. I take this over to the other side, it becomes x is equal to 6. Okay, which part exactly did you not understand? Okay, I'm going to continue with this and maybe we can go back to explain it one more time. Okay, so in this one here, we're going to take a common factor, correct? So it's not trinomial, but it's a more simple common factor. X squared is x minus 6 is equal to 0. And we equate each factor. So x is a factor and x minus 6. It's essentially like having x minus 0 and x minus 6. X is equal to 0 or x minus 6 is equal to 0. So x is equal to 6. Can you isolate x on the first question? Yes, you can. It just depends if they're asking you to solve for x. Okay, is this grade 10 revision? Yes, kind of, it is. it is grade 10 revision, but also introduction of grade 11 as well, because you will be tested in grade 11 as well. Okay, after this, we will be moving on to exponents. Okay, where it gets a bit more intricate. Okay, but we are starting off with the basics. Okay, so you guys can go through these examples on your own. Let's move on to quadratic formula. We're just going to do one example of the quadratic formula. Quadratic formula is given in your formula sheet. This is the quadratic formula. Okay, it says that if you want to calculate the value of x, you're going to use that formula and substitute a, b, c into that formula. Now, how do we get a, b, c? Let's look at this example, right? If we try to do brackets for this example, it won't work. We won't get a factor pair that would give us the middle term in those specific cases where factorization does not work, manual factorization, when you're trying to factorize a trinomial. That's when you have to do quadratic equation. Now, quadratic equation, they'll generally say correct to 2 decimal places because you're getting decimals, all right? And it's a hint in the exam that, oh, okay, yeah, I'm going to use the quadratic formula because they said 2 decimal places. So firstly, remember the format of a trinomial is ax squared plus bx plus c. So if you want to know the value of a in this case, it is 2, the coefficient of x squared. The value of b is the coefficient of x, which is -3, and the value of c is the constant, which is -3. Now we substitute that into this equation. So if I want to now factorize it or solve for the values of x, actually I'll say x is equal to -b plus minus square root. It's not going to work where that worked. Plus minus b squared minus 4ac all over 2a. So I substitute my values. Please use brackets. -3 plus minus. So in my calculator, I'll just do plus in one calculation, and next calculation I use a minus, and I'll get 2 answers. B squared, so that is -3 squared minus 4 into a, which is 2, and c, which is -3. All over 2a, which is 2 into 2. When I do the calculation for this, let me just see what answer do we get. So you can either leave it in fraction form if the fraction form is okay, or you can leave it in decimal form. Correct. So you get 2 options, because remember, you're going to be using the positive and the negative. So for those 2 different things, you'll get 2 different answers. So x is equal to 2,19, or x is equal to -0,69. Okay. So those are your options for x using the quadratic formula, quadratic equation. I hope that makes sense. So essentially, you need to identify what is A, what is B, what is C in your formula itself, in your trinomial, and then substitute those values into your quadratic formula, which has the variables. Again, this is given in your formula sheet, and it's given in place. Like where B is, you're going to put the number, use brackets every time you substitute, put it into your calculator carefully, and do the plus and do the minus, and you'll get 2 answers. Okay. The person that said they didn't understand the trinomial factorization, could you please specify? Do you not understand trinomial factorization? Do you not understand a specific step? Do you not understand the common factor? You could even send me a Q&A. You can even send me the Q&A. The Q&A is like nobody else will see the question if you don't want anyone to see the question. You didn't do this last year. You didn't do the quadratic formula last year. If they tell you to leave it in third form, then we won't SD it. Correct. Yes. If they tell you to leave it in third form, you do not convert it to the decimal form. Okay. You didn't do it last year, but if you didn't do it last year, you'll be doing it this year then. Okay. So would you like me to explain quadratic formula again then? Okay, also anonymous attendee in the Q&A, are you referring to quadratic formula? Okay, no problem. I'll go to quadratic formula again. Okay, let's go through it one more time. We can go through it using the next question, all right? So again, we are dealing with a trinomial. Okay, perfect. Okay, cool. Everyone is asking for quadratic formula. Okay, no problem. Let's go through it slowly, all right, to make sure we understand it. Again, we are dealing with 2, which is HCF from the 1 trinomial. Ah, yes. Sorry. We didn't finish that question, but that was just to learn trinomials. But yes, we should keep it 2 there. Okay, perfect. Let's just continue. Okay, quadratic formula. So when do we use the quadratic formula? We have a trinomial and they want us to factorize or they want us to solve for x. Okay, they want us to solve for x. So they give you x squared plus 10x plus 8 is equal to 0. Okay, in mathematics, in algebra, when you have one unknown, you need one equation to solve for that unknown. When you have two unknowns, you need two equations to solve for that unknown. That's how it works. So in this case, we have one unknown, which is x. And we have this one equation, so we can solve for it, all right? Now, normally when we have a trinomial, we try to factorize using the previous method, right? We call it trinomial factorization, okay, where we open up our two brackets and so on and so forth. So let's try it for this example. So my first factors are x and x. My second sign is a positive. That means both are going to take that sign. So it's going to be plus and it's going to be plus. Okay, this unfortunately, okay, doesn't actually take it. Okay, so both are going to be plus. So in the exam, will they always give us the formula? Yes, exactly. No, the formula does not have to be memorized. The formula will be given in the formula sheet. You can utilize it. It's almost like a cheat. You can utilize it to factorize each time, provided that if you're not going to do factorization normally with brackets and you want to use your quadratic formula, you have to show your equation and your substitution to get your full marks. Okay, but either way, for this specific one, I'm trying to do regular factorization where I open up my brackets and I assume that you guys did this last year, right? This is what you used to. This is the type of trinomial factorization that you used to. But now let's look at 8. Okay, are there any factors of 8 that I could substitute that are going to give me positive 10? Let's consider 1 and 8, 2 and 4. That's it. Those are my factors of 8. Okay, I see. You said 2 plus 8. Okay, we'll get there. So remember, these are my factors of 8. Right now, when I use my factors of 8, I have to use factor pairs. I have to use 1 and 8 because those are the factors of 8. 1 times 8. I have to, if I'm going to use the other one, I have to use 2 and 4. I can't use 2 and 8 because 2 times 8 is 16. Okay, do you understand? So I have to use the factor pairs. Right? I either have to use 1 and 8 or 2 and 4. 1 and 8 can give me 9 or 7. If I say 1 plus 8, I get 9. If I say 8 minus 1, I get 7. 2 plus 4 gives me 8. Sorry, 2 times 4 gives me 8. No, we're adding and subtracting, sorry. 4 plus 2 gives me 6, or 4 minus 2 gives me 2. None of them give me 10. That is the point. This type of factorization is not going to work simply because it doesn't really matter. But in this sense, this is now when we use something called the quadratic formula. Okay, when we cannot do, actually, at any point to factorize a trinomial, you can use the quadratic formula. But because we've been used to using manual factorization, we utilize that and it works in all our cases. However, now moving up a grade, right, things change and we have cases where, as you can see, you cannot use the manual factorization method and we have to use the quadratic formula. So quadratic formula is given. Quadratic formula says that x is equal to, so it's giving you a formula to calculate the value of x. B squared, sorry, negative b, not b squared, negative b plus minus square root b squared minus 4ac divided by 2a. So if you want to calculate x, you need to substitute b, a, and c. Now, how do you get b, a, and c? Remember, the general formula of a trinomial is ax squared plus bx plus c. So in this case, a is, somebody tell me what is the value of a? A is the coefficient of x squared. Correct. The value of A is 1, right? Because it's an invisible one. It doesn't have a number. What is the value of B? The coefficient of X. Okay, 10. Correct. What is the value of C? The constant term. 8. Very good. Okay, so now we have those values. Okay, A, B, and C. Now, all we have to do is take A, B, and C and sub it into this fancy equation, which again is given. So all you're doing is subbing it in, right? So to be able to use the quadratic formula, I'm not sure if that's a question. Okay, so now negative. Please, whenever you are substituting in maths from today onwards going forward, if you have not been doing this before, use brackets. When you substitute into your calculator, when you are using your calculator, you need to use brackets. So negative is already there. What is B? 10. Plus minus, meaning in my calculator, I'm going to put 1 plus equals 2, then go back, put a minus equals 2, get two different answers. B, I'm using brackets. 10 squared minus 4 into what is A? 1 and C 8. Again, I'm using brackets. It matters mostly when you have negatives. Divided by 2 times A. What is A again? 1. So now in your calculator, you take it out, you create a fraction, and you start. You say negative, open brackets, 10. Then you say plus. And you're going to say square root, open brackets, 10, close your bracket, squared. This is all inside of your third. Minus 4 into 1 into 8 divided by 2 times 1. So when we use positive, our first answer is negative 5 plus root 17. So x is equal to negative 5 plus root 17. Okay, this is one term. These are not like terms, so we can't add them together. So that's fine if you leave it as that. You can even convert it to a decimal by pressing SD. You get negative 0.8788. Sorry, if you round off to 2 decimal places. I'm not sure if this is what someone typed in the chat earlier. Or alternatively, so you just go back into your calculation. Don't redo it. Just press the up arrow key or whatever arrow key. You can just go back into the calculation, change that to a minus. And you get the next answer, which is negative 5 minus square root 17, or alternatively in decimal form, negative 9,12. Correct. In the marker song, if you don't put the plus minus next to the square root. Essentially, they could, like someone could not, like a teacher could not see that because it's like a formula that they just expect you to copy down right, but put the correct formula. Technically, they could take away a mark from you, but you don't want to take that chance. Okay, so yes, therefore, we have our answers for x. Okay, so we have to do the plus and we have to do the minus. Okay, so that is the quadratic formula. I hope that makes sense. Okay, so you can do the example, you can do the same for 4 and for 3. You, A, B, C, you sub it into the quadratic formula. Okay, let's talk about completing the square. Okay, so completing the square, firstly, it says step number 1, write in standard form. So no problem, you're welcome. So step number 1 is write it in standard form. So standard form again is our ax squared plus bx plus c. Right? If you remember from parabola, there's like turning point form and other forms. Maybe here we have like root form, whatever different forms we can get of a trinomial, right? But they say it needs to be in standard form. Okay, so we have this that's in standard form. Number 2 is move c across. So that's step number 2. Always to take c to the other side so that we're left with x squared plus 2x is equal to positive 1 when we take it over to the other side. So this is factorizing using completing the squares. Okay, let's do number 3, divide both sides by a. Yes, correct. We only use quadratic formula when the trinomial formula doesn't work. Technically speaking, you can use the quadratic formula even when your trinomial formula is going to work. You can use the quadratic formula at any point in time. Myself personally, I preferred to use the trinomial formula when I could, and then use the quadratic formula when I couldn't. And you'll see, like in difficult questions in physics, if for those of you who take it, you'll only like mostly be able to just use quadratic formula. I just feel like quadratic formula, sometimes it's tedious and it takes up time. And if you're quick with the trinomial formula, it's much quicker, right? And if you've been working for it for a long time, yes, quadratic formula works all the time with every trinomial. It will work. Okay, so x squared plus 2x is equal to 1. Move c across. Divide both sides by a. Okay, so remember, now they're talking about like a and c, as in ax squared plus bx plus c. They're talking about those coefficients of the variables. Okay, so divide both sides by a. So in this case, in most cases, a is 1. So you're going to divide both sides by 1. It's going to be the same thing. Okay, but that's just a step you must ensure to do. Now, step number 4, important. Add half times b squared to both sides. So what you have to do is you have to take b. Let's just write it above b. A is there. And that's actually c. So you have to take b, half it, and then square it. Take b, half it, and then square it. B, which is 2. So I'll tell you, you have to actually add it to both sides. So I'm just going to write out what I have so far. And then I'm going to take, let's actually do this. I'm going to add, because they say add, half times b squared to both sides. So I'm going to take b, which is 2. I'm going to half it. So the easiest way to half it, express the half of it, is to just divide it by 2, just like that. So I'm going to say 2 divided by 2, and that number I'm going to square it. And they say add that to both sides. Then I'm going to have my 1, and I'm going to add 2 divided by 2 squared. Sorry, I should be using that. So I'm going to take b, half it, and square it, and add it to both sides. Okay, hope that makes sense. Let's simplify. So 2 divided by 2 is 1. 1 squared is 1. 1 plus 1 is 2. 2 divided by 2 is 1. 1 squared is 1. This whole thing is 1. This left-hand side 1 is 1. Plus 1 is 2. Okay. Please will you send the rules and steps also? Yes, I will. These notes will be sent to you. Okay, so yeah, I have x squared plus 2x plus 1 is equal to 2. Okay, so now how do I go further? So the easiest step is this will actually always form a binomial that has been squared. Okay, so essentially their factors are the same. The easiest way to remember is you're always going to turn this into a factor. Okay, whatever the first sign is here, you copy that sign here. So if the first sign is a plus, that's a plus. Why do we need to add the 1? So that's the rules. In order to factorize completing the square or solve for x, completing the square. Is there another formula for completing the square? I think all have like along the same lines, doing this exact same steps. Maybe slightly different explanations, but all will be along the same steps. Okay. So whatever the first sign is, that's going to be the sign there, number 1. Number 2 is the square root of the first term, which is normally x, goes there. Okay. And also, what number goes here? Basically, I'll add it in the notes. All right, I'm going to add it on the side before I send it to you guys. But the number you got from from number 4, this value becomes the second term in the bracket. I'll go through it again. Exactly, 1. So when we said 2 divided by 2 and we squared it, we got 1. And that's what goes there. Wait. Let me just think. Is it before the square? Just give me 1 second, guys. I just want to verify something. Before the square. Yeah, before the square, correct. Okay, so not particularly this answer. Okay, I'll phrase it, okay, but I'll re-explain it one more time so that we understand it. So basically, the number you get, I'll go through this whole thing again, don't worry. The number you get when you take b divided by 2. So let's just say what goes here is b over 2, essentially. Okay, and equals to 2. So in this case, it's x plus 1, which is b over 2. Okay, is equal to 2, but squared. You square that bracket. Okay, please, you take the number that you got after multiplying the coefficient of x. Please re-explain. I'm not sure I understand what you mean by that. Okay, so in this case, what you're going to do is your square root of the first term, okay, and b over 2 is your second term, okay, which in this case is 1. We square it, and we square the entire bracket, and we equate it to the other side, which is 2. Okay, it's not yet done. I will do another example shortly. Okay, so it's not yet done because we still need to solve for x. So now in order to solve for x, the next step is to square root both sides, because how are we going to solve for x? We need to get rid of the square. So we're going to square root both sides. Square root, square root. Okay, when I square root this side, I get this square. Let's just use black. This square cancels with that square. So I'm left with x plus 1. And remember, when you square root both sides, you're going to get plus minus root 2. So here you have x plus 1 is equal to root 2, or x plus 1 is equal to negative root 2. Yes, the square of the bracket goes for everything inside the bracket, definitely. Okay, then to solve for x, to leave x alone, here you're going to get root 2 minus 1, or x is equal to negative root 2 minus 1. Okay, so we're doing trinomial. Okay, you could also convert that to a decimal. Okay, let's quickly go through one example. I feel like we need another example. Let's see, x squared minus 8x plus 5 is equal to 0. Do another example that if you divide by 2 isn't equal to 1. Okay, that should be this example here. So is it easier to use fractions or decimals? I think if you're meaning in general or for your answers, it's a personal preference. Sometimes the decimal is very long, and then you can represent it as a shorter fraction, so that's easier. Sometimes teachers want specific things. Aren't you supposed to introduce the plus minus when you're putting the square root? That's what I did. When you square root both sides, oh, you mean like on this step? Yes, correct. That's technically true. I think this is what you mean. Okay, let's do one more example. So this is completing the square. Okay, we're going to follow it step by step. I will write up with these rules as well, the rules neatly. Okay, so that you have, you must always end up with two answers. Generally, yes, you will. Okay, so that you have a step-by-step method that you can follow. Okay, let's go quick. I have load shedding, I think, in like 5 minutes. So completing the square. Firstly, write it in standard form. That's done. The second step is to take c to the other side. So x squared minus 8x is equal to -5. The next step is to divide both sides by a. Again, in this case, it's 1. So you're going to divide both sides by 1. It's not going to change the value. Yes, correct. Thank you for that. Okay, so now we have x squared minus 8x is equal to -5. Now the next step, number 4. Add half times b squared to both sides. So essentially, we need to divide b by 2 and square it and add that to both sides. So x squared minus 8x, okay? What are we going to do? We are going to add b, which is 8, divided by 2, and square that number. This is going to be equal to -5 plus 8/2 squared. Okay, so somebody asked, can we use the quadratic formula for this one? So it is a trinomial. Okay, so at the end of the day, yes, you can use a quadratic formula to solve for a trinomial, but the question will specifically state solve for this or solve for x using by completing the square. That's what the question will specifically state. Okay. So yes, now that we've added that, we can simplify. So I'm going to have x squared minus 8x. 8 divided by 2 is 4. 4 squared is 16. And I'm going to have -5 plus 16. That's going to be it's going to be +11. Okay, are we all on the same page so far? How do you know when to use this? The question will specifically tell you you need to solve, you need to factorize this or solve for x by completing the square. Mr. All Caps. Okay, so now here's the tricky part. Okay, so the idea here is to open up your bracket. Okay, have the square root of your first term. So in this case, my first term is x squared. You see, that's why you always want to get rid of this coefficient, right? No matter what. In the next lesson, we will do an example with a coefficient. Then I can show you as well how we deal with it when it has a coefficient, right? So in this case, the square root of x squared is always going to be x squared. So here we're going to have the square root of our first term. Technically not a, but I suppose let's just say ax squared. Okay, basically it's the square root of our x squared term, because remember it's a trinomial, so it's not going to get bigger than a square, right? So here is going to be the square root of our x squared term. This sign is whatever sign that's there. So this sign is a minus. Whatever is our first sign of the trinomial, translate over to our bracket. So it gets minus. It becomes a minus. Okay, and yes, this one is going to be b/2. In that case, b is 8. b/2 becomes 8/2, which is 4. And you square the entire bracket and equate it to 11. Where does the 8/2 come from? Yes, it says it in the rules. It's part of the rules. You need to, for your fourth step, you need to add to both sides b. 8/2 comes from b/2. You need to divide b by 2 and square it. Is b not -8? So the negative has already been compensated for this by this. Because remember, all we are doing is we are expressing this in terms of brackets. We are factorizing it. If you'd like, this is a shortcut. If you'd like, you may factorize it. You may do trinomial factorization. Let's do that. I have two brackets. I have x. I have x. This is a plus, so both become minus. Is that clear? I'm going to use trinomial factorization. Both become minus. Okay. In that case, I need to use the factors of 16 that are going to give me 8. It becomes minus 4, minus 4. So that's how we end up with x minus 4 squared is equal to 11. Maybe let's not take that shortcut. Maybe let's factorize our trinomial and group it with an exponent just like that. Maybe that's easier. So you leave the negative by B8. You only use 8, whether it's negative or positive. It says it in the rules. It's B not negative. But either way, it will be positive. It's squared. Yeah, that's why it's plus 16. Exactly. Because when you do FOIL, actually, to open it up, it's negative 4 times negative 4. But that's just the ruling. If you do want to take the shortcut, whatever the sign is going to be the sign in the bracket. Don't worry about this. I know it's weird because normally you always want to consider B, but this is completing the square. It's very specific rules. Okay, I think maybe factorizing it as a trinomial is better and then grouping it as an exponent, because I think a lot of you are used to trinomial factorization already. And then we simply solve. So we're going to square root both sides. Plus minus. That cancels with that. You're left with x minus 4 is equal to positive root 11. X minus 4 is equal to negative root 11. X is equal to root 11 plus 4. X is equal to negative root 11 plus 4. So the method we learned, we don't take the C value over and the answer in form example C-2 is correct. Yes, that should be fine if that method works. If you don't take the C over, because eventually you will end up with the same answer. So that's fine. Very similar. Okay, but yeah, slightly different if you don't take the C over. Is this revision of grade 10? Kind of, but many people don't really remember completion of squares, and many people have not learned quadratic formula in grade 10. So one more thing I want to just wait before you guys go. I'm just answering one question on thingy. Okay, cool. No problem. You guys are welcome. So listen, we will be figuring it out. Like with regards to the lesson and what lessons we are going to complete, which topics we are going to complete in which lessons. Okay, so going forward, hopefully in this week, I'll be able to send you guys a timetable so that you guys are more prepared on which topic we are going to be doing for maths, for physics, whichever ones you guys are joining for. And yeah, hopefully we can benefit you guys and improve your marks. And we will be, we will be communicating to you guys any updates or any sort of things, any important things that you guys need to know. Okay, so for now, I'll send these notes tonight, and if you guys please go through it and practice, and I will see you guys next week, inshallah. No problem. You guys are most welcome. I'm glad that you guys found it beneficial. My teacher stopped by the bracket squared. Okay, so it just depends. If they tell you to solve for x, if you are solving for x, you would then take it a step further to actually solve for x. Okay, perfect. Okay, cool. Thank you guys so much for joining, and I will see you next week. We have a raised hand. Okay, I have like, sure, one person can talk. One question quickly. Okay, actually, I'm not sure if you raised your hand by mistake. What I'm going to do is I'm just going to end it here. I'm just scared the load shedding is going to come before, and I won't have the opportunity to end it. And I will see you guys next week. So yeah, all the best. Okay, cool. We'll try my best to do that. Thank you guys so much. Jazakallah khair. And